Hi everyone, this is Mrs. Torigno, and this is the second page of the second packet of the semester exam review for Algebra 1B. So this video will cover questions 5 through 10 in that packet. Okay, let's start with number 5, and I got several questions on number 5 in class over the last couple of days. In number 5, I started by just rewriting the equation that's given to me in the problem up here so that you can see it a little better as I'm pointing to it, because we're going to have to use a couple of different numbers out of that equation to answer these questions. The questions that I'm asked about this parabola, which, by the way, you could graph on a graphing calculator and use that to answer some of these questions as well, but you don't actually need to, is does it have a minimum or maximum? Which direction does it open? What is the vertex? And what is the equation for the axis of symmetry? And my advice to you is actually to answer letter B first, because once I answer letter B, I can find the answer to letter A. Which direction does it open? Remember, parabolas can open up or down. So here's an example of a parabola that opens up. Here's an example of a parabola that opens down. Okay, the smiling face and the frowning face. There they are. Parabola that opens up and a parabola that opens down. Okay? And looking at the equation, we can tell right away which one it's going to be by looking at the value of A. And remember from when we talked about vertex form just a moment ago, that the A value is the one right here in front of the parentheses, so it's that positive 3. If that A number is positive, which it is in this case, our parabola is going to open up. If that A value is negative, it will open down. So, like I just said, this 3 is positive. That means this parabola will open up. And that's all I need for my answer for letter B. Okay? Now that I know it opens up, I know it looks something like this. Okay? So to answer whether it has a minimum or a maximum, I want you to notice that this parabola starts here and then continues up forever and ever. Okay, so is there a lowest point on this graph or is there a highest point on this graph? Well, there can't be a highest point because, like I said, this goes up and up forever. It's never going to stop, so there will never be a high point on the graph. But this is the lowest that this graph is ever going to go. So anytime your parabola opens up, it will have a minimum value. Okay. All right, part C wants to know about the vertex of the parabola, which again, you could take off a graph on a graphing calculator, or you can just look at the equation itself. Remember that on the previous page, we talked about vertex form of a parabola, and this is written in vertex form, which means that if I compare it to what vertex form should look like, the H and the K are the numbers that tell me my vertex. Now you have to be really careful here because there's a lot of places to make mistakes. First of all, when we name our vertex, we have to name H first. And H is the number that's in the parentheses with X. Okay? So first we're going to name the 4 and then we're going to name the 2. The other thing we have to watch out for is in our formula, this formula has subtraction signs in it, which means that those minuses are built right into the equation. So when we pull the numbers out of the equation, we need to leave the minuses behind. And that means that this positive 4 is really a negative 4. Okay? Because the only way this could have been a plus is if we would have put minus a negative in there when we put the 4 in. So when you pull the numbers back out of vertex form, pull out the X and then the Y, and also take the opposite of the numbers that are listed. Okay, so here my vertex would be -4, comma, +2. It's like they're upside down and backwards. Okay. Letter D is asking for the axis of symmetry. The axis of symmetry is that vertical line that runs up and down the middle of a parabola. And it's actually really easy to find once you have the vertex. The axis of symmetry is always just x equals the first number from the vertex, or h. So here I would say x equals -4. Be careful though, and remember that when you write the equation for the axis of symmetry, you have to include the x. You can't just say -4. You would have to say x equals -4. Okay, let's try the exact same thing with problem number 6. And once again, I'm just going to rewrite this problem here so that you can see it a little better. Y plus 1 equals -2 times x minus 1 squared. Again, I'm going to start with question B and answer what direction does it open. To answer that, we're going to look at the a value, which is the -2, and that means this time this parabola is going to open down. Okay, so which direction does it open? It opens down. This time, you'll notice that this parabola extends downward forever and ever and ever. So we're never going to reach a lowest point, but we will reach a highest point. Okay, so that means this graph has a maximum. Anytime a parabola opens down, it will have a maximum value. Okay. Now the parabola's vertex, again, I can take right out of the equation. Okay, so let's practice what we just talked about a minute ago. First, I'm going to pull the x number, and then I'm going to pull the y. And I also have to take the opposite of what they look like in this equation, because this equation turned them negative when those numbers were put in there. So this is really a positive one, and this is really a negative one. So my vertex would be 1, -1. And then do you remember what we said about the axis of symmetry? The axis of symmetry is always x equals the first number from the vertex. Okay, so our axis of symmetry here would just be x equals 1. And again, make sure that you are including the x in your answer. Okay, let's move down to problems 7 and 8. Well, let's move down to problem 7, and then we'll tackle number 8. Number 7 is a little bit complicated in that it takes several steps to actually answer this question. Okay, now I've taught you with word problems to jump to the end of the problem and figure out what it is that you're being asked for. In this problem, at the end of the question, it's asking you what would the cost of a 2-hour job be? Well, you're not going to be able to get that answer directly because you need to know how a 2-hour job is calculated. So I'm going to go back and read the rest of this problem. Jeanette hires an electrician to rewire her kitchen. He charges an hourly rate plus a flat rate service charge. So it sounds to me like these are the pieces that I need to know to figure out a total charge. I need to know an hourly rate and I need to know a flat rate. Then it goes on to describe how much she would pay for a 3-hour job and how much she would pay for a 5-hour job. And it wants you to figure out what a 2-hour job would be. But I can't answer any of those questions until I know this hourly rate and this flat rate. So I'll start by defining my variables. I'm going to say h is my hourly rate. And f is my flat rate. I'm going to try really hard to stay organized on this problem because there's a lot going on here. Okay, so there's my variables. Now I want you to think about this 3-hour job. If somebody hires an electrician for a 3-hour job, they're going to end up paying the flat rate plus 3 hours. Okay, so think about what that would look like in an equation form. We're going to pay the flat rate plus 3 hours, and it tells us in the problem that that will equal $236. Okay. Now we're going to do something very similar for this 5-hour job. We're going to pay the flat rate plus 5 hours, and our grand total there will be $360. Hopefully here you'll notice that this looks like a system of equations. That's exactly what this is. Okay, this is very similar to the problems we did on the very first page where you were finding x and y. And this one looks like it'd be really easy to solve with elimination because everything lines up really nicely already. And these f values would be really easy to cancel out if I could just make one of them negative. So it doesn't matter which one you choose. I'll take the top equation and I'm going to make all of these values negative. So that gives me a negative f, a negative 3h, and a negative 236. And now I'm going to add those together going up and down. So my f's cancel out, which is exactly what I wanted to happen. That's the whole reason I set up this problem this way. Now I'm going to take negative 3h plus 5h, and that gives me 2h. And negative 236 plus 360 leaves me with 124. Okay. Final step here would just be to divide by 2. And I come out with h equals 62. Okay, so the hourly rate here is $62 per hour. Okay. Now I need to use that hourly rate to go back and find the flat rate. So that's sort of my next step here. And I can choose either one of my original equations to plug into. I'll just choose the second equation because I didn't mess with it at all. So that I don't have to worry about whether or not to keep it negative or positive. I'll just work with the one that I didn't mess with. So I would say f plus 5, but then now I'm going to put 62 in for h instead. Has to equal 360. Well, 5 times 62 is 310. From here, I would just subtract 310 from both sides, and you should come out with f equals 50. So this flat rate, or the service charge, is $50. Now, after all that work, I'm still not done, because the question is asking not what the hourly rate and the flat rate are, but how much would it cost for 2 hours with this electrician. I have to zoom out to give myself some more space here. Okay, so off to the side over here, and hopefully you can see that okay. Yep, looks like it. Off to the side over here, I need to figure out what a 2-hour job would cost. And remember that for a 2-hour job, I'm paying 2 hours plus the flat rate. So I would say the flat rate plus 2 times the hourly, which is 62. And when I evaluate that, I end up with $174. And that finally is the answer to this question, is that 2 hours with this plumber would cost $174. Okay, so there's a lot of steps there. There's a lot of things you had to find out before you could even answer the question. Okay. Fortunately for you, or maybe unfortunately, question number 8 works very similarly. Okay. Question number 8, Nikki is joining a gym where she pays a flat membership fee and a small fee for every visit. So again, I'm going to start by defining my variables, and you will find that very helpful in these types of problems. Okay? So this time I'm going to say that F is my flat rate. Again, that's what she's paying up front. And V is the rate per visit. Okay, so she pays this much just to join the gym in the first place, and then she has to pay a small amount every time she actually goes. Okay. So now, she visits the gym 10 times this year and pays $105 total. Remember that $105 does not just cover the 10 visits, because I see a lot of students wanting to just take $105 and divide by 10. This $105 covers the 10 visits plus the flat rate, and you don't know how much that flat rate is. So here's how I would set up my equation. I know I'm paying the flat rate, and I'm paying for 10 visits, and total that'll equal $105. Then she figured out if she visits 18 times, she's going to pay $129. So there she'd be paying the flat rate plus 18 visits, and that would equal $129. Okay? Once again, now I need a way to solve this. Now, you certainly could use substitution here if you really wanted to, But I just like the way these are all lined up. They're really well suited for elimination. So I'm going to pick one of these to make everything negative. I'll just pick the top one again. And again, I did that so I could get my F values to cancel out here. So F and F cancel out. Negative 10V plus 18V is 8V. And negative 105 plus 129 is 24. Divide each side by 8. And we end up that each visit is going to cost her $3. Okay. So there we solved for V. Now we're still going to need to go back to find F. I'm going to take that 3 and plug it into either equation. Again, I'll probably just stick with that bottom one since I haven't messed it up too much. So I'm going to say F plus 18 times 3 equals 129. Well, 18 times 3 is 54. So F plus 54 equals 129. Subtract that 54 from each side. And that comes out to, oops, sorry about that. That comes out to $75. So my flat rate is $75. Once again, we're not done because this question wants to know how much would she end up paying if she had to visit 26 times. Okay. So remember, she'd be paying this flat rate, this $75 membership fee, plus she'd be paying $3 per visit for 26 visits. Okay, so here's what that would look like. Here's my flat rate, and then I'm paying for 26 visits, so 26 times the $3, and 75 plus 26 times 3 leaves me with a grand total of $153. Now, I really want you, when you're doing a problem like this, to think about your answer at the end and make sure it makes sense in terms of the problem, okay? If a 3-hour job only costs $236 and you came up with something bigger than that here for a 2-hour job, I would hope that you would catch that you had made a mistake there. Similarly here, if she's visiting 26 times, that better cost more than visiting 18 times. So if you got something that really didn't mesh with these numbers that are given to you in the problem, take a second and go back and try again. Okay, don't just say, oh, well, I got it wrong, I'm going to move on. Okay, I know that happens way too much. Okay, let's jump down to questions 9 and 10. And I assure you, 9 and 10 look way more difficult than they actually are. Okay. Question 9 is asking us, for what value of n does the system have infinitely many solutions? Here's n right here. Okay. Actually, I think I'll take this one and rewrite it on a blank sheet of paper so that you can see it a little bit better. And okay, so here's problem number 9, just written separately so that you can see the numbers a little bit better and so that you can see what I'm pointing to. I'm trying to figure out what value of n here would give me infinitely many solutions. Now, when you're solving a system like this, you'll end up with infinitely many solutions if every single thing in the problem cancels out when you do elimination. Okay? So let's start by thinking about what we would need to happen to have the x's cancel out. And I want to think about how I could turn a 2x into something that would cancel out with a 6x. The answer I get a lot is that I could multiply it by 3. Well, multiplying by 3 would turn it into a 6x, but 6x and 6x don't cancel out. We need one of them to be negative. So I want to actually multiply this top equation by -3 to get my x's to cancel out. So -3 times 2x is -6x. -3 times -3y is +9y. And -3 times 10 is -30. Okay, so this here is just this equation rewritten after I've multiplied everything by -3. Okay, so now I don't even have to worry about this equation anymore. Okay, now I'm just focused on these two. Notice that the way I have things now, my x's are going to cancel and my numbers at the end are going to cancel. And now all I need to answer is what would I like n to be to get it to cancel out with that 9? Well, if this is a positive 9y, I'd love for that to be a -9. So my answer there for number 9 is n equals -9. That's it. That's all that question's asking you, is what would you like n to equal to get everything to cancel out? Okay? And problem number 10 is very, very similar. Let me rewrite that one real quick. Okay, there's problem number 10. Now if you look back at your packet, this question is asking how I could get it to have no solution. When you're doing a problem like this, you would have no solution if your x's and your y's canceled, but these numbers on the end don't necessarily have to cancel. Okay, so it's really still similar to this. We're still trying to find something that would help my n cancel out. But I don't want that n to cancel out until I'm ready for my x's to cancel out here. So I have a -3x down here. That means I would want this x to be a positive 3x. So I will take this top equation and multiply everything here by 3. That will give me positive 3x, positive 6y, and positive 33. So that's that multiplied by 3. And again, once I've multiplied that by 3, I really don't need that top equation anymore. Okay, I've turned it into a new equation now. So now my x's cancel. And these numbers don't cancel this time, but that's okay. I don't need them to. Because for no solution, we want our x's and our y's to both cancel out, but to still have some numbers left over. So if I want my y's to cancel out, and this is a 6y, think about what you would want your n value to be here to cancel out with that. If this is a positive 6y, I would need a negative 6y up here to cancel. So I would really like my n to be equal to -6. This question is really just testing your ability to see what a system looks like when it has no solution or when it has infinitely many solutions. But it's not nearly as complex as I think a lot of students think that it is. Okay? That's it for this page. That took us through problem number 10. Next up will be page 3, which covers 11 through 17. So we'll see you in a bit.